Okay. Okay. Okay, so why is our camera very small? So make it okay there. This larger. Make this smaller. Yo. This gonna work. No. Mouse. Yeah. Mouse works. There you go. Snap. Alright, cool. Make this smaller. Alright, there we go. Alright. Let's open our terminal. Terminal. Open our notes. So yesterday, yeah, we fixed the tmux switching bug. And if we take a look at dot files, so let's take a look at last 3 commits and then the code. Not too much, but scripts, Python, core. Do we have any core? Core, yeah. So the fix was this tmux switch. So I just flipped the sequence. So instead of like doing an attach first, because what happens if you attach from a tmux pop-up, if the session is available, the switching happens from within the pop-up. But if you already have an existing session, it's proper that you use the switch subcommand instead of attaching. So let me show you the problem. So we have the tmux, and then let's say display pop-up. So it's gonna show this. Let's see. All right, so we have 2 sessions from here. If I tmux attach, so that's a shortened version to say, and then we target. So currently I'm in dot files. If we target notes, it's gonna attach from within this pop-up window. We don't want that. What we want is to do the switch, switch -t, and then that's yeah, it switched us to that. But this pop-up is still here. It's not gonna show up if I executed that from the tmux binding key bind I have. So let me close this out. Oops, what happened? So it closed my, yeah, it's still there. So let's see. So I just triggered that. And then let's go to our dot files. So yeah, it switches me properly. So I really have to, what do you call that? Yeah, I don't have to check for, or yeah, I'm not getting a duplicate session error. So yeah, that was fixed. So let's take a look at yesterday. We did that. We learned how to use Python, PyNVim, so to interact with the NeoVim instance via RPC. But I was thinking maybe let's just go with curl. So I'm gonna create a library because I don't LF. If we do a search, so nvim lua curl API. So there's Planary. Okay, so Planary is available. This is good. Actually, let me just clone Planary. So this is gonna be a plugin. Yeah, we have GitHub. We clone that. Let's take a look at how that code is implemented. Alright, we have curl. What's a curl spec? Is it a test? Yeah, this is just a test. So let's read this. We have a couple of curl methods here. We have the URL, query body, the request body. The query is the URL query. Okay. Auth, yeah, form raw. So does it use? Okay. Then how are you sending the request? So fold method expression. Yeah. Okay. So we have this parse request line 33. So let's go there. Open it up. So this is your request. SSLs. Okay. But how are you actually doing the call? Peacock p.new table and compat. Here is the request. Is this the request? G. So you're taking parse.request request. Question. Okay, so you're making a job. What's J? J is Planary job. Okay. And then you have some job options here. Your job options is you have a Planary command or curl. Okay. And then you have some arguments that you passed. Gotcha. Okay. So, yeah. Let's see. Planary. There's a lot of people who. Okay. All the functions I don't want to write twice. Full, complete, entire, absolutely qualified. Useless outside of NeoVim. Vim should be usable with any recent version of NeoVim though. At the moment, it's very much pre-alpha. Okay. KKK. Yeah, but I think. Yeah, maybe I'll just use. Yeah, I'll write my own. So let's go to our dots. To nvim. And then from here, let's take our curl. I think this is where I would want to start. It's not really sh that I want to run. It's actually curl that I want to run. So this, you're gonna have a set of flags. Each flag may have a value, but sometimes it doesn't. That should be okay. So what that means is, let's say you have local flags, and this is going to be a table, which is a list. And say each flag is again another list. You have the first value as your flag key, so let's just call it key. That's gonna be a string, and then an optional value. Okay, so these are your flags. So for every flag, location. If you say location, let's take a look at curl -- location. Okay, location is if the server reports that the requested page has moved to a different location, indicated with a location header, blah blah blah. L is limit the amount of redirects to follow max readers. You can tell curl to not change post requests to get after the method set with X. Request provides method curl, providing L multiple times. Yeah, I don't understand. You have an example. What it's saying is, if it's moved to a different location, 3xx response code. This option makes curl redo the request on the new place. If used together with I include or I headers from all requested pages are shown. When authentication is used, curl only sends its credentials to the initial post or host. If a redirect takes curl to a different host, it doesn't get the user password pass on. When a curl follows a redirect, if the request is a post, it sends the following request with a get. If the HTTP response was 301.23, curl resends the following request using the same unmodified method. Curl to not change post requests. Yeah. Yeah. Yep. So we don't really need that. Anyhow. So it can be whatever. We're not gonna have any defaults. It's just gonna be an empty table for now. And then, so you have your URL. This is a string. Okay, and then, so you have your flags. The data of the flags is a let's see, so it's a string. Everything is a string. Okay, so basically what I want to produce is something like this. Then I can start with that. So this is a sample post. That means I should have show data automatically in first. Yeah, man, curl dash data. Alright, so there. Sends specified data in a post request. So it's automatically inferred that you are doing a post request. Alright, cool. So that's cool. Now, so we have your command, which is fixed. Go to line 23. That's your command. Let's comment this out. Let's not do anything for now. Our goal is to just produce that sample. So let's do print for now. Let's return whatever is produced. Let's say, let's start with flags. Flags, result, flags, results. So what I'm gonna do is flags dot for do I have for our I pairs, index pairs? Well, don't really need the index. So let's just do a for pairs. You got your key and value. So this is going to be flags. Yep. Flags. You are taking it from here. Request flags. So let's just do our flags is equal to flags. Right. So let's just pairs. Our flag. So for every key and value, for now, let's print them. Key. Value. And then yeah, that should do a lot of stuff. Little file, execute the current file. What it's saying is bad argument. You need to pass a table. Yeah, let me pass a table. Alright, okay, so there's an error. Oh, wrong. So here, yeah, let's go. Okay, we're getting, no, because there's nothing to execute. Every item in the list. Oh, okay. So I think, yeah, let's just do something like this for now. Test test key is that. Test value is this. Now, key here. Run that. Okay. Then I think what we want, let's see. Wait. Flag result. Because since this vim dot inspect key is 1, which is the index. Let's do the same here. Vim inspect. Alright, cool. Oh, value. Okay. So we don't need the index. So we don't need that. So let's not do that. And then we're gonna do it again. So we're saying for every flag, that this is gonna be our flag. inner flag. Right. Let's just say this is your flag. Right. Okay. For every flag, you have a key and a value. So you definitely want to inspect that as well. Can I destructure it? Like, key, value, from flag. I don't know if this is gonna work, but let's see. Print key, value. Right, it didn't work. Destructure a table. Lua destructure table. Unpack. Gotcha. So you're saying you want to unpack table dot unpack. You have your list. Then what does it return? Integer. Returns the elements from the given list. It's the equivalent of, okay, I is just one. Right, so let's hold on. View documents. Yeah, let's view documents. Oops, sorry. It's GX. Right. Unpack return list. By default, I is 1 and J is length of the list. Just the elements from the given list. Elements. Attempt to call field unpack. Flag unpack. Okay. Vim.table unpack. Returns the elements from a given table. Unpack our flags. Prints. It's a table, okay. Vim.inspect. Yes. So you have your key and value. If you unpacked, so this is a table with a table. Okay. Then why did it not print that? No. You did unpack the flag, which should have a value. If you underscore, what's the value of underscore flag again? It's a table, so we should be able to unpack a table. Right. You're able to unpack a table that has a key and a value. if you do unpack that, you're getting a nil. That is odd. Returns the elements from the given list. Well. Unpack values. So you have values 1, 2, and 3. Oh, it's like you're passing. Gotcha. Okay. So I guess let's not do that. So you have your flag. Should have a, I don't know, a key and a value. Print that. Do the same here. Print. Whoa. How do you access that? Same here. Value. Your flags are, oh, test. Okay. Test. Key. Test. Value. Alright, so you have a key and a value. We can access them via dot. Alright, okay. So for every flag that we have, we're gonna construct a string. So that would be, these two will be joined. So I guess I should be able to just write curl from within that. So why don't I just use curl? If I use curl, I should be able to craft the query easily. But if I pass the data, I need to figure out. Okay. SH. Well, I guess that should work. I don't really need this. So yeah, let's just, so today we're deciding not to use curl, Lua for invoking curl, because we can invoke it via and then we can invoke it via system, vim not system. Yes, so we can do this. So I guess let's just do this. Makes it easier. Yeah. Chat completions. Now that I'm getting those results, so I'll just make proper handling, adding tree setter. So if I do tree setter, right, let's try testing tree setter. So what custom LLM utils. So tests, tests. We're saying learn tree sitter dot nvim. So nvim tree sitter. And also let's try Llama. Let's make go to home. I don't have a home directory. Home. Yeah, let's go here. LLM model is default. Quencoder. Okay. So let's ask it. LLM explain tree sitter or basic nvim tree sitter example. Parse markdown. Right. So you have that. Tree sitter. Markdown file. Get nodes. Yes. So you have the parser and it has some utils. Whoa. Let's read it. Get the current buffer's text. So you have a table. Which accept lines and a new line. Okay. And then you have a function to parse the buffer and get the nodes. Right, so you have your text and then you have your parser. Get parser 0. Markdown. What does that mean? Parser get parser. And tree sitter get parser 0 markdown. Parser parse. And you get your text. Okay, so that's how you get the tree. Each tree has a root, and then you have a node. Okay. So where is the call? Traverse and print nodes. Root parse. Buffering get nodes. If root, then traverse and print nodes. Okay, so that's the call. Parse, buffer, and get nodes. So you have your text, you have your parser. You get the tree. And then you return the root. Okay. I have tree sitter installed, so let's make this a note. Yes, this is that URL. Actually, GitHub URL. All right. Let's add this copy link address. Tree sitter. Oh, it's not loading. Why? Why? It's not loading the image. That's weird. Downloads. Let's download this save image. It downloads logo. Right. PNG. Yeah. I don't know why it's not downloading the stuff. Image.nvim. Oh, wait. That's odd. Okay. So Tmux will, yeah. Tmux shows because you're still on it. Okay. I understand. So we don't want that. Oh, wait. Where are my notes? Yeah, cause, she said yesterday. We're doing that today. And you have your tree sitter here. Let's do our markdown preview. It's not even showing the previews. Okay. That is weird. That is weird. It's not rendering images. Like, why? Why? I have the URL here. Logo. Tree sitter. Why though? Markdown, preview, and image. Local images. So it does support local images. Images path. Markdown images, but I did use an absolute path, so that is weird. If I do yeah, shows, so I don't know what's up about that. Oops. Not. Yeah. These are images. Oh, you can even control the size. Okay. Right. Why is synchronized logging? Linux. Small number. Oh, that image is working. Okay. Well, that's, because clearly this is also an image. It's a PNG. That's a GIF. So somehow this logo is unparsed HTTPS user images. So this is an absolute path which opens. So I don't know about that. PWD. Pass that to sh. So that's our current working directory. Word. So this not being concealed. Conceal level. Okay. Something's fishy. Just why? It's not loading that. It is loading that. So what the hell is wrong? Now it's loading it. What I have here is the same thing. So if I just use, okay. So you don't like it. If it's, yeah, so we have a tree sitter logo. It's not loading it from there for some reason. Which is weird. Because clearly it should. Right, okay. So I'm just gonna move this, downloads. Documents. Notes. Where's my notes? Desktop. Notes vault. Gotcha. Okay. Assets, images, should be media. Media. Right. Tree. Sitter. Logo. Oh. What's wrong? CD downloads. Whoa. It disappeared. We don't know what's going on. the tree sitter logo. Alright, music. Cool. Copy that image. Let's try to paste that image. Tree sitter. Wow, it's not loading it. That's weird. What is it? Yeah. So it knows about it. Okay. Okay. There we go. There we go. Alright, so we have some notes on how to use it. So let's use it. The second sea level. So let's try to fix that first. Image and image and configuration, render cursor. So you have this clear and insert mode. What does that mean? Clear in insert mode. Oh, okay. Yeah. We're saying as an option in the mark integrations markdown. Options integrations markdown, and then you put that here. So slow that. Go to our notes. Go to tree sitter. It's still loading it. Okay. Obsidian and then image load image cursor. Should be looking for image and then config. Markdown, integrations markdown. Clearly I have this configuration. If I go it went away. Oh, okay. Oh, wait. I see. Notes, tree sitter. So we have a pass through. It goes away. And then image and then markdown only render. Instead of false, we would tell it. Okay. So that's nice. Well, actually, I think I'd prefer having no image rendered. Yeah, no, we're not doing we're not rendering anything. So let's just say Obsidian. Obsidian. UI enabled. Okay, so it's not enabled. That's good. Image env. Yes, we want to support image env. But let's see. Image env. Maybe there's an issue there. Bug in Tmux. Pass through. Event Tmux. Okay, so I can switch. But yeah, I think for now, let's go with after conceal level. We're not doing that. Just set that to 0. Go back to our notes. No, tree sitter. I don't want image env. And false. Yes. I don't want any default options, to be honest. Tree sitter. Shit. Can I stop it from doing that, please? Yeah. So that means I don't really need image env. Alright, okay. Be next. Okay. Tmux pass through. Well, I should just image law. You know. Patch notes. Resetter. Yes. Alright, that should be good. So let's get back to Lua. Lua test. Custom tests. Person. tree sitter. Ugh. Yes, let's do that. Okay. So we have that installed. Ugh. Okay. Okay. Copy that. So utils is not used, but parser is. Tree sitter utils. Okay, so I have some utilities there. Get buffer text. So if I have a markdown, say test.md. This is your heading, paragraph, some text. So, oops. Yeah. If root, there's buffer nodes. Get parser. Okay. Root. Lua file. Test. Tests. And then tree sitter parser are not found. Tree sitter parser. TS install, yeah. TS install. Markdown. Well, I already have them installed, so I should have a parser. Should have a parser already, yeah. That's weird. Will I require and dash tree sitter dot parser. Module not found. Parser. What did it say? Script just does the following parsers marked down. Tree sitter, TS update. So let's parsers are up to date. Oops. POC. Markdown, sync install true. Little scripts. So that didn't work. env parse file tree sitter. Required tree sitter parsers. S Lua file. Okay, cool. Parsers. Your parser config. And tree sitter parser. Tree sitter parsers. Get parser. Returns a parser for a specific buffer, and it attaches to that. Create a parse. Tree sitter parsers. What's it? Yeah, let's read some docs. Parsers are the heart of tree sitter. Okay. Language, add Python in the path. So you have a tree, and you have your nodes. Okay. Right. Show me the API. Require. Tree sitter. Dot parse. Okay. Do I really need that? Dot get parsers. Local parser. Okay. So that means I don't really need. Okay, so LLM's knowledge is out of date. So we don't. Let's not do any of that for now. So buffer is, let's say you want a markdown file. This buffers. Your markdown buffer is 40. So this is going to be 40. So language that attaches it to language default. Okay, so there's a default value here. Vim.print versus print standard output, converting each argument to a string following the same rules as Lua. Okay, but Vim print, put a print unmodified. Okay, cool. So yeah, always use Vim print parser. So vim.inspect yeah, Lua file, parent file. Yes, we have a lot. So now if we say you have your parser, now vim tree sitter parser. After getting the parser, you want to get the tree nodes, get nodes return the smallest name node at a given position. So get parser dot parse. 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 Query dot parse. LLM logs. Parse. Node. Tree. Parser dot parse. Okay. So you want to get the entire buffer text. So we're saying is we get the entire contents. So let's get buffer, get lines, buffer get lines. Gets a line range from a buffer. 0 till the end. Start is -2. So to get to the last element, use start is -2, end is -1. 0 based. So, and then buff get lines. What? Buff get. Oh, get text is what I want. And then buff text. Right. So what's the documentation from the buffer? Start row. Gets a range from the buffer. Allows retrieving only portions of a line. I think I want lines. Control the. Yeah, so you have your buffer. So buffer number. It's an R, yeah. Buffer NR. Pass that as well there. You have your start, which is 0. You have the end is -1. Lines. Local lines. Then not print lines. So this returns an array, which is a table. Vim.inspect. Alright, so if I execute this, Vim.function, it should be a function, right? I don't know. Alright, cool. So we get that. Children should have some kind of nodes. But you basically... no, sorry. That's incorrect. We only care about the lines for now. Alright. Buff get lines. And then that function. Vim fn. Test. Oh, it's API. Vim not API. 4 arguments. Really? Maybe no. False. Because saying strict. Strict indexing. What does that mean? Code. Oh, shh. Come on. So if I want, there we go. Strict. Whether out of bounds should be an error. Yeah, we don't need out of bounds to be an error. Right, so you have your heading, you have your paragraph. These are all the text. So we have our lines, then we're gonna pass it to the parser. Parser dot parse. And this is taking a range. Maybe, I don't know. Parse a range. What the hell is a range? Parser. A range. Language tree. What's our POC saying? Parser dot or parser. Get parser. You have your parser. You get the text. So you get the text. Table concatenate. So after getting all the lines, you have your table, you concatenate them. Tree sitter parse. Parser dot parse. It's not query, but it's parse. Tree parser parse. Language tree dot parse. Recursively parse all regions. Range is a boolean or a range. What's a range? Parse. Set to true to run a complete parse of the source. Set to false or nil to only parse regions. Range. What is a fucking range? Language tree parse. And then you return. Any region with empty range, typically only the root tree is always parsed, otherwise yeah. Vim.inspects user data 1. What the hell does that mean? Oh, sorry. IDK. It's still user data. That's weird. Lines, what does concat? Google concatenate. String concatenation. Quote operands use strings or numbers, they are converted to strings according to the rules. The house is documentation. And there's the end values at the top. Pops them. Right. Concat is one, or more pieces concatenated, so. Ooh, concatenation, table concatenation. Given an array, right, where all elements are strings or numbers, stable, I dot separator, spawn separator, yeah, default value is separator, so you're joining all of them. It returns a string of all the joined texts. Okay. So then, why don't we go ahead and do that? So for every element that we have here, table.concat, or let's just say concatenation. Lua. Table concat. Table concatenation, right? Lines, and then you have your separator. User data. Markdown text. So print markdown text. Forgot about that for now. Yes. So what you're saying is that you can't read this? Local tree root. So this is now your tree. Tree root. Root is a nil value. Okay. Parser for that file. Yes, info. Configuration information, TS module information, TS buffer, TS install info. Get parser. Oops, wrong. Ooh. Buffer 40. buffers. 20. 40 buffer and R. Still now not getting the roots. TS. Already I'm marked down. Consider commands. Consider playground. Built-in consider live query. Creaser. Creaser query edit. Inspect query. Preview query. Okay, so I have access to the tree. So inspect tree. Those are the commands. Then I should have the parser because parser is being shown. But what's in our parser? Yo, returns a language tree for the buffer. So then cursorily parse in a region with empty range. Yeah. Get lines. Oh, the buff number. Still not working. That's language tree, children, table of immutable. Let's ask what the children are. I'm getting some result. Inline, yes. I don't know what these are. Parser regions trees. User data 6. User data 1. Okay, so that was probably the root. Course, arrange. Corresponding. Contains destroy. Search tree. Language range parse. No. Yeah, let's just read the docs. Tree sitter. Good tree. Language tree contains a tree of parsers. The root tree sitter parser for the language and right, start row and grow for the current buffer. Alright. Whenever you need to access your current syntax tree, first the buffer. Right. So you get the parser for the buffer number. Let's see. Do we get buff and R? How do you get buff info? Get information about buffers. Get buff. Info. Get information about buffers as a listed dictionary without an argument information. Get buff info. Call get buff info. Yeah. 0 is the current buffer number. So you wanna echo call get echo call get buff info 0. Right, okay. Line number, buffer number 10. So buffers, currently that's 10. Get buffer number, buffer info. Gotcha. Okay, so we can do that. Let's make a note of that. This is good. So neovim .md. So echo buff get buff info. Get buff info. Get buff info. Great. Buff and R. Current buffer number. Current buffer's number is always equal to 0. The current buffer's number is always equal to 0. Great. This is Vim script. So if we want to get Lua Vim dot API dot get buff info. Vim dot function dot get buff info. That works. Oops, sorry. So we do a print, right? So it returned a table, and then vim.inspect. Right. Okay. So we are learning NeoVim. Currently, we're in the notes. So Lua, NeoVim Lua, which is, let's just take that. Yeah. Vim CMD. This is a made-up language, but yeah, you know how it is. And I should just say, yeah. And then Lua. Right. Okay. So we can get rid of those. How does it look? C. Oops. Get buff info. List show buffer info. Okay. Cool. Now we can test our tree-sitter. So we have that. Parser gives us a table. Parser parse. Tree-sitter. Parse the request. Node. Oh, this is REST NVim. REST NVim. No, I don't want that. Parse tree-sitter. Parser. Parse. Parser. Language tree parse. Carefully parse all regions in the language tree. Any region. Register callbacks. Trees. Tree-sitter. Okay. So you have a parent, so node. Ending tree-sitter documentation, right? Okay. Parse. Language tree. Get nodes. Get node at cursor. I don't think I need parser. So what the hell is this? Commands. Utils. Functions performance. Okay, that's not what we want. I'm not tree sitter. I'm not tree sitter. Deprecated. Use language tree children. It's non-recursive instead. And then tree sitter markdown. Then markdown. This is the parser for that. TS install, so markdown. And then tree sitter parsers. Markdown. Tree sitter markdown. Okay, cool. So now, usage and editors. Contributing. So this is the spec. Common mark spec. View changes. Whoa. Latest version. Blocks and okay. That's a block. And that's also a block. Okay, let's go back. Oh. Consider parsers. Modules. You have your commands. Modules. Parser install directory Arling parsers. Vim.treesitter dot language set. So it's a Vim thing, okay. Query, get query, inspect, moved. Do we have anything else? And then, resetter. Alright. Maybe this is where, yes. Dual module tree sitter language. Very cool. Add. Get, inspect, register. Dual module, query. We have different modules. So you have get language name. It's a runtime query for edit. Opens a language. Okay. Directives. Parse query as a string. What else? Iter matches set. Language tree. Okay, this is the one that I am interacting with. Returns a map of the language to child tree. Determines whether. So what's child tree? What kind of information are we getting? Research level parse. Let's just get children, yeah? So children level file prints. What is wrong? So we don't really need those. For sure. Yep, sorry. Okay. Have our first index. So if we take the first child, let's just get the first one. How do I get here? What's a chat? What's it returning? It is a table. Okay. It is a table that has a lot of stuff. So you only have one child. To mark down in line. Change tree, child added, removed. Mark down language, mark down. It has a children, okay. I'm not tree sitter. Node. Parser. Language tree. Trees. So I can also get the trees, okay. Trees. Returns all trees of the regions. So empty. Another heading to test text. Trees. Okay. User data 6789. Resetter tutorial overview and examples. Tree sitter. Okay. And tree sitter get all headings. Mark down headings. Hmm. Trees that are get marked down. Adding nodes. Consider queries. Oh, okay. So I guess specific element contents above buffer, parsed contents above buffer. It is a user data. And a user data is what? Data. Block of memory with a given size. Full user data represents it's an object like a table. You must create it. It has its own table. Okay. You have a byte length, a child count, child with descendants. Okay. Descendant for range. And position equals node. Let's read this. Tree sitter node. Alright, I think we can read it better here. So yeah. Your children. So you have a parent, node parent, field. Node corresponding to the name. Turns the table of the nodes corresponding. Table of the nodes. Child count. Child. Start and range. Type as a string. Okay. So I should. So let's say, for example, for each children. Trees. Tree. What's this? All trees. This is a table, integer, and a tree. Okay, so for tree in 5 pairs. Trees. I end. Do end. Fem.print. Fem.inspect. Tree. Yeah. These are data. How do you interact with user data? User data. Read user data, any of them. If the user data meta table is created, it contains an entry name contain new meta table. Unfortunately, this feature is still inspect get meta table, some user data. Inspect get meta table. Get meta table. right? Copy include ranges root. Maybe it's not the tree that we want. Parser. Maybe. What we want to do is actually do a parse. And then this returns a table with a tree. Right. So let's just say this is parsed. It's a user data. Query. Parser.query. What else? Trees. Turns to trees. For each child. For each tree. Language. Parser that. So this is lang. Lang. Right. So, print lang. Okay, so it's a markdown. What else can we do? Print, parser, lang parse range, and it responds with a tree. Again, we don't know how to interact with a tree. Get parser, utils, tree sitter. Tree sitter utils. Status line. Sitter utils. Get files query. Not tree sitter. Yes. Language version. Old expression. Get captures get node. Returns the smallest name node a given position. First via given position. Calling this on an parse tree can yield an invalid node if the tree is not known. They have buffer number. You have an option. Language parser, right? Node or range returns. Node or table of positions. Get node text. Get parser. I think that's what I did. get parser. So it gave me a parser. It gave me a language tree used for parsing. String parser. Inspect tree is ancestor. Now it contains starts tree sitter highlighting for a buffer. Stop. Language. Yeah, I think query is what I want. Predicate, edit, get files, lint, less directives, omni function, a partial language query. Returns a query object which can be used to search nodes. Search nodes. Iter captures. From the source is needed if the query contains predicates. Iter matches. Meta ID. Sit. What? This predicates. Get query. Get files. Gets returns a query. Iter matches returns a query. Parse query as a string. If the query exposes info returns them tree sitter query. Tree sitter dot query. Yeah. Query. First query. A parsed query. What? Tree sitter parse markdown. Sample query. Module tree sitter. For your parse query. Yes. A parse query has these language captures. I don't know what captures are. but you have some query info. Oops, sorry, info. And we don't have any information here. Query info, tree sitter. Wow. Wow.
Hey everybody, today we are going
Yeah.
to be exploring tree particles, which define how you're going to describe the language, and this gets turned into a ridiculous C file. Is not bad. That's out there for this as the guy you can query against the.
Okay, so you have a scheme file, right?
The neovim. Press up yes, right here. You good. Let's put you. I know some people act the more in feature turn thing that we don't want you to we're going like this, and we'll have parsers, and these ones should always be installed. We have Lua here. That's the only one. If you want to add other ones, you know, no country. So I think really do that actually. Okay, and in some highlight all these highlight you
tree sitter Python API. Python bindings, yes, that's, and so we have that, right? So we have the sample, right? After inspecting the result, you have a root node, which is a type of module, and you have a start thing, ending. You have a function definition, identifier, a body, function arguments. Okay, so what I'd like to do is actually get these information from the tree. So that's what I was trying to figure out. I don't see that here.
Right here, parentheses aren't. We can use the beautiful inspect tree. I gotta zoom out just to touch. But function call print.
Oh, okay. Parser.inspect. So I think that's what I was missing. So parser inspect. Parser children. Maybe. And then inspect. Do I have an inspect? Which is a field. Cool. So local inspect. Inspected tree. Vim.prints. Vim.inspect. Right. Parser children inspected inspects. So a children does not have an inspect. Vim tree sitter inspect. Yeah. Tree inspect. Inspect tree. Gotcha. So trees. Inspected, which is a tree. Okay. Trees. What does it respond with? So this is a right, and if I take trees. This is a user data, so that's your first. Yeah, it's nil. Tree. Then tree sitter inspect. Inspect tree. Options is a table. Inspect tree. Open a window that displays. Oh, okay. Tree sitter inspect. Language dot in inspect language. Sitter node represents node parent sibling. Get node returns the smallest node. Node text gets the corresponding query get node text. What else? What else can a node text type? A TS node is nodes type. Gotcha. Get node. Okay, so this is good. TS tree. Tree sitter dot root or root tree roots roots. How do you get the tree? Get tree gets the tree. Language tree for range. Where's the source of the language tree? Tree for range. What's a range? Start line, start column, and line and column. Range. Line numbers may be specified. Node range. Start row column bytes. Range. Lots of ranges here. Tree for range. Start line. Start column and line and column. Tree sitter get parent and get root. Node. After parsing, get the first one. That's the parsing. Get parse So you take the one piece, parse. That's what I did. Easy to get parser. So this is Lua, and their code layout. I don't know what that is. Oh, period I get. Let's go start here. Oh, okay. Resetter query get. Gotcha. Query get query name. What's a query name? It's a string. Say highlights. Query name. So if I look at query markdown tree sitter. Great. So you have common scripts, markdown, inline. What do you have here? You have some queries here, highlights, injections. Queries. I just want to get the rules document block section matches TS node. So if you run a query, right, reset or get parser, parse, and that's your tree, right? That's your tree. Oh, maybe I'm not getting markdown. Okay, markdown. MD get files. Read a file in Lua. Or let's just say a string. Parse. Get parser. Buffer could be nil, right? Default current buffer. Nil. Get parser. Language. Now, this is your language. There's markdown. Get parser. Lan. Buffer number is integer or no. Options is no. Language tree, so I should still have user data. Print inspects. I have a parser. Now, next, get the buffer. Get buffer. Parse text into a file in the open. Actually, downloads minimal. Dot files minimal. No. YouTube present.m present. So this is an example. Oh, I already have that present. Present. Where's the test? Start presentation, make file, present Lua. Parse slides. So that's your text. Essentially, parse slides. Tree sitter get string parser for contents. Content is for every lines, right? Concatenation, get string parser, gotcha. So you're doing that. And so test Lua, or should be nvim. Yeah. Get parser. So this should be vim not tree sitter dot get string parser of a string. So this is a string, right? And this is going to be marked down. Okay. Take all that. Makes it easy. Close that. We actually don't need that anymore. And then you have your, let's go to present. Yes. So this is your roots. Yes, and that's your parser. That's your parser. You have your roots. Parser dot parse. Right. Right. Take this. This is going to be our markdown now. Text. Yeah. So our root is vim print vim not inspect. We'll file. That's odd. So we have the root here. Iter captures contents section query. Are you saying that I should? I see. I should have a query. Okay. Then I have to learn that. Okay. Inspect tree. Edit query. TS edit query. So this is your heading. H2 marker, H1 marker. tx. And then can we have an inline? Let's say Fensco block language. Oh, user assistant. Okay, this is good. So I should be able to parse all these. So you have your user, you have your assistant. Now, actually, how about we do LLM, and then from here, how do we structure user? This is no, we don't want that. User assistant block quotes response for user prompt assistant assistant response. Ew. Right, okay. If I want to do it I don't know, it looks ugly. Yep, it's ugly. Can't be like that, because the user can yeah, I think that's so we can say detail summary. Test. Collapsible section markdown. Details. Nope. Details tag. So you have a summary there. Let me copy this. Paste it in here. Oh, okay, so it didn't. Okay. So I could say okay, so I can say this is your summary is user. What is the meaning of life? details is going to contain lots of text. Alright, cool. How do I add? Alright, cool. So we have that HTML block. Oh, it doesn't know what this is. Then we don't want that. Or I don't know, maybe we do. Yeah, so prompt assistant message. So this is your message content choices. Content. Right. Cool. Alright, cool. Cool. So I need to make a query just for parsing the oh, okay. So I can say that this is the question. So that can be a chat. Okay, gotcha. So let's define, yeah. So I think I have this. Yes, we're learning. Need query to get the tree. So read the file contents as a string, and parse the string contents as or pass the string contents to them.treeSitter.query to get the tree. Yes. So what we did here is test tree sitter test tree sitter. Yes, this is your notes. So this is your code. Right. So take that right. So we have all these. Tracer. So this is for getting the root. To get the root. Inspect root, which is not useful. But yeah, you have the root, and you still need. We need to get the node. Need to learn how to get the node. But the idea is LLM Markdown. So date. Lua date. Or Python date. Get current date Python. Date today. Get current date. Lua. Wow. I like this better. Easy. Oops. WV. Take that. So. Lua. What? Vim.print. Oh no. That's ugly. So this is your year, day, year, month, day, 17. Okay, cool. So, we should make that. Yeah, year, month, day. Don't need hours. Yeah, we don't need those. There we go. Pass it to Lua. Are we missing anything? Unfinished string, because we're missing. Yeah. Cool. Alright, cool. So. There we go. Okay, so let's link it. So the idea is some time ago, this was old. Execute a user command. For example, LLM. With a visual selection of the user prompt. You could also I think as it first. Or maybe. So I want So this is as a user, right? So if you have a markdown and then you have your prompt here, the moment you close it, but basically you take the last prompt as your query, right? The way how that's gonna look is that well, yeah, I like the one that has a summary. So just where is that? Test details. Test MD. Yeah, I like this better. So let's do that for now. That's going to be our example, right? Example. You have your user. Yeah, and then outputs this. But yeah, let's just take this respond by adding a markdown contents with the format as follows. That's your example. As follows. Oops. Sheesh. What? I can't. Alright, cool. There we go. That's your example. Okay. Maybe let's just do it this way. Right, so that's your prompt. Oh wait, hold on. Begin summary. Summary have JS. Console.log. Oh no, it can't. Yeah. Oh no. So this won't work. details. Prompt assistant message. What's our format that we can fold it? POC. Right. Markdown preview not found. Why? Okay. So this is an example, right? Okay. So you're actually doing that. But I'd like to be able to interact with it directly from NeoVim. So what I would do is LLM logs. Let's see. LLM logs help. There's a list right off on path status list. In model query usage extract conversation ID current. Okay. Number of entries to show default use 0 for all. So I can't. You have a prompt and response, right? Okay. But these are all in a database. So I don't know, path, right? If I do SQLite, what's this? SQLite, PC SQLite 3. So if we do a query on select attachments FTS LM migrations responses prompt response index config conversations ID. So you have conversation ID. It's a reference that you have a prompt in the responses, and then the stable is responses. Add prompt attachments conversation ID response text. So everything is in the responses table. Responses. Is there a way I can output to JSON? Alright. Cool. Alright, so you have that. Let's just take one entry. Okay. Test. Have your response as a markdown, right? Prompt JSON, prompt response. Okay, cool. So we have this in the database, right? Should be able to talk to it. This should be the same, right? Conversation ID last. Holy shit, it's 3 a.m. Gotta sleep. $78. Let's do English. $95. Mm-hmm. Well, slow, slow, slow. Mhm. 96. Let's do code. Python. Mm-hmm. 83. Oop, oop, oop. Death ad begin. $89. So what's our trending today? Glance. XPipe Go Cursor. Free code cap. Scheduling infrastructure absolutely for everyone. R8. Develop software autonomously. This is a Python again. Deep researcher. Research stage. multi-step planning, automated command execution, leverage expert reasoning models. The agent can use advanced reasoning models such as one just when needed to solve complex debugging problems or in planning or for complex feature implementation. Web research, Tavily API. So this is at web research capabilities, 3-stage architecture, research, planning, implementation, RPI. Research, planning, implementation, architecture. You have your research stage, planning stage, implementation. You have a console processing, text modules, core components. Got you. Okay. Let's go ahead and do that. So this open source Apache license. What does that mean? Well, what does Apache 2 license mean? Oh, this is for coding. LLM models. So you want DeepSeek, Hashem. Actually, yeah. But anyhow, let's go to GitHub. Git clone that. Right. So you didn't think. Apache license is a free open source license originally created blah blah blah. In practice, due to its flexibility and alignment with modern open source practices, refers to the Apache no guarantees report. Apache license free open source. So allows for distribution under or any other open source license. Designed to encourage reuse of open source projects through open community license. Okay. No patents, no restrictions, no guarantee of support. Okay, cool. So what's default, or let's say -c difference between MIT. Wow, quick. Trying to understand what's the difference between MIT and Apache. Yep, I should break down. I might be missing. In summary, okay, cool. Difference between is you have your patent grants, free riders clause, versioning, community, summary, and practice. Is straightforward for those who prefer simplicity without patent considerations, whereas the Apache license offers more flexibility, but with varying implications based on the version used. Gotcha. Okay. MIT does not have a specific version. Cool. So MIT is more straightforward. But anyhow, Tavily, connect your LLM to the web. So what's our pricing here? Free. Every month you have 1,000 credits. Pay as you go. You have a project. You have. Wow. Slide to adjust plan. 500,000 or $500 per month. 25k. Is it? Yeah, 525k a month, which is 100,000 calls. Okay. But do you like DuckDuckGo API? Oops, sorry. AZ. Switch. What's our... No? API. DuckDuckGo API. Documentation tell you how to Google. What's your pricing? Pricing. You also offer Privacy Pro. No API? As others mentioned. So you have a limited search API. Please note that this is not a full search. Okay. That works, yeah. Where's the API though? It's not saying API page. Search API. Freedom. So there's a content moderation. DuckDuckGo. Not what I want. So screen scrape. GitHub. Oh wow, it's big. Great. Requirements. What else does it have here? Applets version. Yeah. Python version is 3 dot. I thought Missy use well, should be this. Tools. So this, where's your components. You have your text, truncate, extract, process, tools, text, processing. TS. Rough and pyrite is here. And then ensure installed tree sitter. Mason LSP config. I'll just add Python here. No. Tree sitter. Sort. Oops. There you go. Says Vino is not executable. And try to see. Check health. Python. Import neovim. Gotcha. Okay, cool. No worries. Python provider. Pip install neovim. Environment is system wide. Check health. Python provider. Reloaded. May disable this. Python provider. Alright, so this is where we want the Python provider to be enabled. Must be set before any. Okay, let's do that. So let's go back to Vim. Python version 3.13. That's the latest. v.mis say use Python. Right. Config miss. And then from here we are going to Python -m vm vm. Alright, source bin activate pip install I in vim. I don't know what any of them is for. Okay. And that's where your provider Python G let's go. So options, we're gonna set that here. G.p. Oops. Ho ho ho. There you go. So going back here, tools, text, or let's say processing. Okay, so that works. Truncate, process thinking. Think tag, supports thinking panel, show thoughts. Process model response content. This function centralizes the logic for extracting and displaying thinking content for model responses. Think tags are structured thinking content. What else are the tools available? Tools, right? Fuzzy find. You have an agent. You have an expert. You are prompt system. You must give the shit context. Prompts. So you have some built-in prompts. Human expert. This module. Expert. If you need additional guidance, analysis, or verification, expert is really good in logic. Consultation. If you need additional expert. If you have any doubts. KKK. Session chat. Prompts. Expert prompts. Console tools test server. Models, agents. Let's take a look at this implementation agent. Okay. Run a planning implementation. Main task, the main task to plan implementation form. Memory instance, okay. Memory management. Implements repository pattern for database access. Key fact. Repository key snippet. Repository key research note. Reset memory, okay. Fixture for test initialization. Set up in memory database for testing. Mux test key facts single event. Search notes. Reset work clock, deregister, task completed. Memory. So what I did was a planning agent. So if we take a look at memory here, it uses LangGraph, okay. So you have a checkpointer, your agents. What? Then how are you using this? Agent utils initialize fallback. Run agent. Planning prompt. Okay. Current date. Working directory. Keep it simple. You have your project information, research notes, key facts, key snippets, environment inventory. Make use of the environment to get your work done as efficiently and as accurately as possible. We are using a library and it's not found in the inventory. Now they include linker flags to your make files, flash command, etc. You must explicitly include any paths from the above info if needed. It's not automatic. Read, yes. Wow, this is really big. Guidelines. If you need additional input or assistance from the expert is available especially for debugging. Scale. How do you inject expert section? Once you're absolutely sure you are completed planning, you may begin to call request task implementation one by one for each task. If you have any doubt, expert human web research. You've often been criticized for overcomplicating, doing redundant work, asking the user if they want to implement. You must focus on this base task. It takes precedence over. Do not write any files yet. Code will be written as you call. Expert guidance section. Never announce what you're doing, just do it. Work and test incrementally. Okay. So let's take a look at agent. What's checkpointer is used for? optional memory. Okay. But we know that check pointer is used for create agent, build agent, quarks, memory saver. Memory saver, memory check pointer, create model, create agent, search, reset memory, wipe project memory. In memory DB, database manager, key fact, tools, test memory, key fact, models. Database architecture, key fact, stores important facts about your project. Key fact, repo. Database repos, key fact, getter. Oh, okay. Yeah. So you have these key fact, and you have what? Wait, key fact. Okay. Wait. I've seen a lot of key fact earlier. Gotcha. So this is key fact repo. Gotcha. Okay. Model get update. Key fact model. Key fact repo. So I'm interested in test agent. So you have a test agent. Test key fact repo. All I see are tests. Repositories in it. Key fact repo. Where is it being used though? Key fact. And session. It's not used anywhere. Initialized, check dependencies. Key fact. DB. Spawn agent. Even there, not being used. Fact count. What else? Get facts. ID. Oh, okay. Okay. Facts dictionary, key facts. Gotcha. Run agent with retry. So, chat prompt. Key facts. Chat mode. In this mode, you'll function as an interactive agent that relies on direct human input to guide interactions. Initialization. Gotcha. Okay. It is pretty. It's similar. So, new buffer. Key facts. Working directory. Oops, what happened? Current date. Yeah. Working directory. Current date. Ew. I don't know. Star. Star is the same as that. So key facts, key snippets. So that's okay. Okay. So memory is used here. So run agent accepts so key facts, get a list of dictionaries here. And that's just being injected here, key facts. Okay, so it is a JSON injection. Cool. Right. What else? Form changed files. Open Sora. Soldi. Wealth management. Ooh, like that. Let's check that out. What problem? Mr. Rep is a blogger that has a spreadsheet in which he tracks his net worth. Aims to replace the spreadsheet and make it easier. Let's take a look. What's it look like? Flutter app is developed using Flutter. Solely expenses. Even recurrent ones tracker, income tracker, bank accounts balance without the use of API basic stats. It is stored only locally. Solely demo phase 1. Okay. What else? PSP, Android emulator, AI chat, Shell Assistant, Azure, Home Assistant, Utils, Trellis, Faster C, Tiny Mist, it's tiny. Integrated language typist. Okay. event loop sanitizers. Sand wine.